Okay, so we still have two more gates to cover. We have got XOR and XNOR. These are called exclusive gates. So this is like the X sign right here, then the X sign right here. This represents exclusive. So both of them are called exclusive gates. So if I want to draw them, the XOR gate is just an OR gate, just a simple OR gate, the way we drew earlier. Wait, not this. And then we just draw a line here. And XNOR is just a NOR gate, just a NOR gate. So we have that tiny little ball thing here, and we put the same line before. That's it. That's XOR and that's XNOR. So what's XOR? XOR is a device that takes in two inputs and exactly one of them can be true. Exactly one can be true. So if I draw the XOR gate, if I draw the XOR gate, and if I take in two inputs, let's say input A and input B, and we have got an output. So if I do take, if I make the truth table out of this, A, B, and out. So if I start from 0, 0, 0, 1, 1, 0, 1, 1, so if I have 0 and 0, it's an XOR gate. This is an XOR gate. So exactly one needs to be true. Exactly one. That's the only criteria you can follow. You cannot break that. So 0 and 0, the output's not going to be uh, a true signal. It's going to be false because XOR means exactly one needs to be true for you to get a true signal. And true means 1. False means 0. So this is going to be 0. This is gonna be 1, 1, and this 1 and 1 is gonna give us 0. Why? Because it's breaking our statement. It's not following the XOR rule. XOR rule states that it has to be exactly one input. That's true. If I follow, or now let's see, let's try to build this XOR from basic gates. How do we do that? At first, we need to create an expression from the truth table. So when do we get the output to be positive? I mean, the output to be 1, the output to be true. We only get it when it's 0, 1, and we only get it when it's 1, 0. So we can write the output. We usually label it as F. You can write F's equal to when it's not A and B, or when it is A and not B. So you can write it like this: A, sorry, not A and B. So this one, and so this or this, sorry, not and, this or this. So it could be not A and B, or it could be A and not B. This is the expression for our truth table. So using this expression, we can make an XOR gate out of basic gates. So I need not A and not B. As you guys can see, I need not A and not B. So the most basic way to do that is I'll take A and I'll pass it through a NOT gate. So I get a NOT A. I'll do the same thing with B. I'll take in B and I'll pass it through a NOT gate. I'll get NOT B. Now I need not A and B. I need to connect them together. How? Using multiplication, meaning using AND. So I have to take input from B and not A. So I have to connect not A and I have to connect B. How do I do that? I can just take the signal of B from here. You can draw it anyhow. It's not like there's a fixed way of drawing this as long as the logic's correct. So we can just pass this through an AND gate. This is B, not A. So we'll get the first part of our final answer, not A and B, not A and B. And now we need A and not B. How do we do that? Exactly the same way, A and not B. So we can just pull a line from A and we can pass it through an AND gate. And it's going to be A and not B. But that's not our final answer. There is a plus in between. There's a plus. We did get these two, but we have to add them up, and the way to add them up is by adding an OR gate. So we can add an OR gate, So how do we draw an OR gate? This. And then we get our final answer.